Hello, everyone. Welcome to our focus session on saline agriculture for sustainable food security in the Kingdom of Saudi Arabia. My name is Dr. Vanessa Melino, and I'll be hosting this session. I'm a research scientist here at the Center for Desert Agriculture in KAUST. Today's forum will be, I'll give a little opening introduction and then a biography of each of our speakers who are joining me, two of them are joining me virtually, and one will hopefully be here in person shortly. Then there'll be an opportunity for you to ask questions as well from the audience and online as well. So let's start. Yesterday, we heard much about the impacts of groundwater limitations in the Middle East and specifically in the Kingdom on food production. But the challenges that we face from increased salinization of water and soil was only briefly mentioned. I think I captured the word salinity twice yesterday's session. So this is what today's session is all about. So the FAO released data from a spatial survey of soils globally last year, reporting that 3% of topsoils and more than 6% of subsoils are affected by salinity or sodicity. Soil salinization impacts on agricultural productivity by degrading soil structure, reducing fertility and availability of soil micronutrients. And we heard yesterday from the ministry about micronutrient deficiency in the Kingdom, for example. And soil salinization also reduces water uptake by plants. But it has a larger scale impact on ecosystems affecting, for example, the water and nitrogen cycles. So how are we faring in the Middle East? Well, the UAE, Oman, Jordan, and just to the east of Yemen have areas of intense salinization where the yields of most current food crops are limited. Unfortunately, the Kingdom of Saudi Arabia is not represented in this global soil map. It's okay. Oh, yes, I understand. So the Kingdom of Saudi Arabia is not well represented with data. So it's related to lack of data availability. And we heard yesterday in the panel on environmental change and also in Professor Mark Tester's opening discussion that limited data availability really affects our decision-making locally. However, there is data on specific regions in Saudi Arabia, like the Wadi al-Dawasir, where cropping is completely dependent on groundwater, and overexploitation for irrigation has led to more than half of the area characterized as high or extremely high salinity. And this is excellent work done at the King Abdelaziz University. So both water stress and increased salinization of groundwater has led to even the abandonment of land in areas of Saudi Arabia. So how do we face these increasing challenges of salinization to sustainable food security in the Kingdom? Well, we turn to successful and innovative programs in the greater Middle East. I say greater because we have a member from Pakistan here. And we take learnings from their efforts. So in this panel session today, we'll hear from these experts who work on biosaline agriculture and the solutions they've brought forth. And this is really an opportunity for you as the audience members and perhaps fellow researchers or fellow members who make policy decisions to ask questions and be involved in this forum. So this is meant to be more informal than the previous sessions we've had. So I will just introduce our panel members here today. So seated with me in person is Professor Bilquees Gul. Hi, Gul. I'm sorry, terrible pronunciation. Professor Gul. She's the co-founder and former director at Dr. Muhammed Ajmal Khan Institute of Sustainable Halophyte Utilization at the University of Karachi. She's completed several projects on utilizing saline land by using non-conventional crops. And we're going to hear that a lot today, non-conventional crops to combat food scarcity in arid regions. She was awarded her PhD from Brigham Young University in the United States. And she's the recipient of several teaching and research scholarships, including the Best Scientist of the Year by the Pakistan Academy of Science in 2005. Secondly, I would like to introduce virtually Dr. Alejandro Rios Galvan, who is the Director of the Sustainable Bioenergy Research Consortium, Chief Research Scientist at Khalifa University. He did his PhD in 2007 at Cornell University in Civil and Environmental Engineering. His interests include renewable energy, climate change and environmental systems design, and we'll hear about that today, and public-private partnerships. He is responsible for the seawater engineering and agricultural systems facilities and growing both food and fuel using desert lands irrigated by seawater. And we really look forward to hearing about Alejandro's work. Thirdly, we have Professor Abdelaziz Hirich also joining us virtually. He's an assistant professor of biosaline agriculture at Muhammed VI Polytechnic University. He's at the African Sustainable Agriculture Research Institute in Morocco. Prior to his current position, he was at ICBA in Dubai. And he has a PhD in agricultural sciences, which is well rounded off with a master's in land and water resource management and an engineering diploma in horticulture. Dr. Hirich has led several projects within the context of biosaline agriculture in several countries, including Morocco, Egypt, the UAE, and several sub-Saharan African countries. So he has a range of experience in a range of arid and hyper-arid environments. And I'm really looking forward to hearing his work about treated wastewater practices and growing alternative crops as well. So I would like to open this session by asking the first question. And my first question to Dr. Bilquees is, what innovative approaches will help us produce food, forage or fuel in arid regions in the face of increasing salinization of land and water? And I'll come sit down over here and we'll listen to her answer.
Thank you, Vanessa, and thank you for inviting me here in this focus session. Actually, I belong to Pakistan, and Pakistan is a semi-arid country, more or less the environmental climatic condition like Saudi Arabia. So I and my institute and my colleagues are working on different aspects of halophyte, how to use halophyte salt-tolerant plants or non-conventional crop to utilize saline or degraded land and for the cultivation purpose. So basically, my work focus on 2 SDGs, zero hunger, and the other one is utilization of the lands for sustainable development. So I've been involved in several projects to utilize saline lands for the cultivation of non-conventional crops. And the most innovative work, actually we are working on the different aspects of halophytes in our institute, and how can we use halophyte plants for food, feed, fodder, ornamental, edible oil, and biodiesel purpose. So different peoples are working on different research focus. Some are working on edible oil, some researchers are working on the molecular aspects. And my focus is to utilize saline land and grow non-conventional crop for the benefit of humankind. And I have already patented a cropping system with the help of non-conventional crop, a very highly salt-tolerant grass, Panicum turgidum. In this patented system, we used Panicum turgidum as a fodder crop and growing with the highly salt absorbing plant Sueda fruticosa, and to balance the soil salinity. So we already I had completed 4 or 5 years of my field work at Third Desert of Pakistan, and I'm working with the Sinangro Coal Mining Company, and they provided me the land, and the land is salinized, and I'm using the brackish water for irrigation, and that water which comes from the out of the mining operation. So we have already developed a model. You said that cropping system there, and now I am trying to modify the productivity, or trying to increase the productivity of that fodder crop by using different soil combinations, biochar, and some enzymes and other stuff. And now I'm also trying to grow some other halophytes that can be used as a fodder or food or edible purpose or medicinal purpose for the local people. So.
Thank you very much. So it sounds like it's not a one crop solution. You need a mixed cropping system, and it's quite a complex system.
Yeah.
Working in.
Yeah.
Okay. And I'll ask the same question. We'll move on to Dr. Alejandro. You can hear me? Okay, so the question is, what innovative approaches will help us produce food, forage, or fuel in arid regions in the face of increasing salinization of land and water? I'd love to hear from you. Thank you.
Thank you very much, Vanessa. Hopefully you're able to hear me. So thank you for the invitation. And as you mentioned before, I represent the Sustainable Bioenergy Research Consortium, which is a consortium of different companies that have come together with the purpose of studying the field of terrestrial salt-tolerant plants, in this case, particularly halophytes. And the companies that are within the consortium are interested specifically in developing a clean alternative way of producing feedstock for the production of sustainable aviation fuel. The reason I'm saying this is because the companies that are part of the Sustainable Bioenergy Research Consortium are the Boeing Company, which is the largest aircraft manufacturer in the world, Etihad Airways, which is the national airline of the UAE, ADNOC, the Abu Dhabi National Oil Company, Safran, which is a French-European conglomerate in the aerospace and defense industries, General Electric, which is also another big player in the aircraft engine world. And we also have a German engineering company called Bauer Resources as part of our consortium. What we have been doing over the last 10 years is trying to develop what we call the seawater energy and agriculture system. The SEAS, as we know it, is a system, like an integrated system that encompasses several subsystems. Essentially, we take seawater and we pump it inland, and we use it to feed an aquaculture farm. And so this farm, in this farm, we grow fish and shrimp. And as these animals grow, marine fish and shrimp, and so as these animals grow, they generate waste, and that waste goes into the water. And what happens is that we need to change this water frequently. What most aquaculture operations around the world do is that they take this seawater and they dump it back into the ocean in the hope that the waste will dilute in the body of water that the ocean represents. What we do is we take this water and we use it as a liquid fertilizer to irrigate fields of halophyte plants in our second subsystem, which is our halophyte agriculture subsystem, where we are cultivating an annual halophyte. In this particular case, we are using Salicornia bigelovii. Salicornia is an oilseed plant that produces tiny oil seeds that contain approximately 30% vegetable oil in them. And so as the water moves back to the ocean, we make it pass through our halophyte agriculture subsystem. The Salicornia plants, while they grow, they absorb the nutrients that are coming out of the aquaculture farm. They absorb the nitrogen, the phosphorus, the potassium. And so in essence, they are cleaning the water in this process. And then as the water continues its path back to the ocean, we make it pass through our third subsystem, which is our halophyte agroforestry subsystem. And as the name suggests, we are cultivating a perennial halophyte. And in this particular case, we are using the Avicennia marina mangrove, or gray mangrove, as it is commonly known, which allows us to remove any remaining nutrients that may still be in the water. And also, of course, it allows us to remove carbon dioxide from the atmosphere, because as you know, mangroves have a very extensive root system and are very efficient at storing carbon in the soil. And so in this way, the water that eventually returns to the ocean is water that is in the same condition as the water that originally came in. And we are producing food in the form of fish and shrimp for human consumption. We are producing biomass that can be used to be turned into a usable form of energy. And we are cleaning the water and cleaning the air in the process. As I mentioned at the outset, the idea is to be able to produce a sustainable aviation fuel. And so what we do is that we take these oil seeds that we have produced in our agriculture subsystem, we crush them, we obtain their oil, and we put this oil through a refining process that is essentially identical to the refining process of crude petroleum. It's a hydrocatalytic process. We use hydrogen and catalysts to convert this vegetable oil into a synthetic paraffinic kerosene through the hydroprocessed esters and fatty acids process. And again, in the end, what we would like to see be produced at scale is a sustainable aviation fuel. And so this is as your question suggested, this is it's a solution that could be explored and that has been explored for over the last 10 years. We, in 2016, we inaugurated our pilot facility. It's a facility located in Abu Dhabi in the UAE, specifically in Masdar City. It's a facility that covers 2 hectares or 20,000 square meters. So it's essentially a microcosm of this system. We have 6 ponds where we are growing fish and shrimp. We have 8 fields where we are cultivating Salicornia and other halophytes that are found here in the UAE. And then we have 2 swamps or 2 wetlands where we are cultivating mangroves. And so in this particular case, our pilot facility is landlocked. And so we manage the system accordingly by making sure that the salinity remains at the seawater range. And going through this process, we have been operating the facility over the last 6 years. And so we are now ready to move to our next phase of the project, which is to build a facility of up to 200 hectares. So we're growing from 2 hectares to a facility of up to 200 hectares. And this will be happening in the next 3 to 5 years. And I'll stop here just so that we can continue the conversation. Thank you.
Thank you so much, Alejandro. I visited the SEAS facility recently, and it's a wonderful example, I think, of biosaline agriculture and great potential as well. We'll come back to you in a minute with more questions, but let's move to Abdelaziz. Again, the same question: what sort of innovative approaches will help us produce food, fuel, or forage in arid regions in the face of these challenges of salinization of land and water? Thank you.
Thank you, Vanessa. And first of all, I would like to thank KAUST University for this invitation. So as your question mentioned, that there is several approaches actually to address the problematic of salinity. Here in Morocco, and especially in the south of Morocco, so we are running several projects on biosaline agriculture. I mean, the south of Morocco, it's a desert, which is a bit similar to the Gulf desert or Saudi Arabia desert. So the approach that we are following here is integrated approach, involving, several components: the crop, the soil, and the water. So we are focusing, for example, in the soil component on testing, several organic amendments. So organic amendments, according to our result, they increase the yield like twice or 3 times, compared, for example, to the control. So the organic amendment, they play a very important role, especially when it comes to a smallholder farmer, that they have in their system the animal component. So which is the case here in south of Morocco. So smallholder farmer, they have this component of animal, breeding, and they have also livestock inside the farm. So by using amendments, so they can increase, and improve the productivity of the crops. In the crop component, actually, we are working on alternative forage crops, especially because here the salinity of the groundwater is much higher. I mean, to produce like food crop or vegetables, etc. So we have like a limited choice of crop, and mostly forage crop. They are, mostly, advised actually, or can resist to this level of salinity, except, for example, quinoa, which is another facultative halophyte that can resist to higher level of salinity. So we are working on several alternative forage crop, and we are working on several what we call best practices, biosaline best practices, especially intercropping. So working on intercropping, we are working on legume grass mixtures that also they have also an important role as well. And we are working on amendments. We are working also on planting method. So, for example, for some perennial grass, the sowing. This is just an example. For example, if we do the sowing directly in a saline soil, so we have like a low germination or emergence rate. This is why actually we are testing transplanting. So we produce plant and then we transplant them, or even to use the cuttings as well is very important than direct sowing. So this is one of the an example of the best practices that we are trying to to test, and the result they show really they have great benefits for the whole system. We are working also on the value chain, because to address the problem of salinity, we need also to address the value chain issues and component also. So in the value chain, we are working to improve the seed production system, the crop production at field, also the transformation and valorization of the produce. I'm just here citing the example of a project, about quinoa value chain, where we developed several, food product as well. And we integrated in this project women cooperatives. This is also one of the social, component of the value chain, to integrate, women cooperative, farmer cooperatives, etc. So, of course, we're working also on marketing of this new crop. So basically, the alternative crops, they are new to the market. So we should not just focus on the agronomic part, but we need to focus on the whole value chain and more precisely, the market, because you are trying to develop some new product and to introduce them to a market which based on the what we call the traditional habits, food habits, etc. This is what happened with us with quinoa. So what we tried to do, we tried actually to introduce the quinoa product in the traditional habit, into traditional dishes, etc. And it was actually quite successful. For example, producing couscous out of quinoa. So we know couscous is like a Mediterranean or North African famous dish. So we're trying to develop this kind of recipes based on this product. So basically here I mean briefly that there is an integrated approach, should not focus on one component, so we should focus on the whole value chain. I mean this is you know, our approach to address the problem of salinity. Of course, there is the irrigation management on it, you know, the leaching fraction, the irrigation system that based on drip irrigation, for example, a sub irrigation system. So all this kind of technologies, they also, I mean, can be used in integrated approach with other components as well. Thank you.
Thank you very much, Abdelaziz. I think it's really interesting, the work you're doing, taking it from the agronomy side of things, which we all know growing crops in saline land or with irrigated salt water is difficult and has its own challenges. But I love that you're moving all the way through the value chain as well. So this, I think from listening to each of you, it brings me to my next question. How important is it to engage in these partnerships with either growers or private companies when you're growing these alternative crops? And you know, are you facing challenges associated with moving into forage crops, for example, with the panicum? Could you start?
Yeah, I had faced several challenges and still facing several challenges. It is really very hard to convince policymakers and the business community to invest on biosaline or saline projects, because business community, they are just, they don't want to invest money on a long-term projects. And biosaline agriculture is a time-consuming project. So it is really very hard to convince the policymakers and business community in Pakistan, as well as funding opportunities. We don't have enough funding agencies. There are two funding agencies in Pakistan: Higher Education Commission of Pakistan and Pakistan Science Foundations. So they just gave us a seed money, not enough for to do a you know, very novel kind of work. So these are the challenges that we are facing in Pakistan.
Yes, thank you. And could I also ask Alejandro to answer the same question? How important is it to engage with private partners or growers for these alternative crops?
I mean, clearly I'm a bit biased on this, but I definitely think it's critically important to be able to build strong private-public partnerships that will allow this type of industry to take off. You know, the saline agriculture industry, in essence, doesn't really exist as an industry. And so in order for us to be able to establish it, we need to be able to participate together and to build coalitions between policymakers, between governments, between private companies. And in the case of the aviation industry, it's you know, it's been quite it's also been quite challenging because, you know, obviously, as I mentioned, saline agriculture is essentially non-existent. And so in order to be able to develop it and to have enough production from saline agriculture to actually have a somewhat of a supply of oil into that could be converted eventually to jet fuel would take several years. And so as Bilquees has mentioned, it's very difficult for people to have that vision of you know, essentially 10, 20 years and invest in projects that could potentially, you know, elevate this type of industry to a place where it can start growing and start, you know, eventually expanding to more land. And so the way we are trying to do this is essentially through a private-public partnership. We are building what I would call a financial scaffolding that will allow investment from the private sector, investment from the public sector, and will allow the support from the government entities that are to make sure that the project is able to move forward. In our particular case, it's the Ministry of Climate Change and Environment here in the UAE, who has been very supportive of the project. And of course, we're also working with the Ministry of Energy and Infrastructure. And so again, beyond working with the private companies, you have to involve the government sector, and you have to involve the people. We're working with the financial sector. And in order to convince the financial sector, you have to go out and do a proper due diligence and convince people that their investment will be taken care of. And so it's not an easy proposition, but it's something that has to be done in order to enable this, or to unlock the potential of this industry as we move forward.
Yeah, you've made some great points there, and I think you described also your upscaling of your pilot facility. So clearly you've been very good at being engaged with both public and private partnerships. Abdelaziz, could we ask you the same question? How important is it to engage with these public and private partnerships, and also new growers when you're talking about alternative crops? You're just on mute.
Yeah, sorry. So yes, it's a very important question and issue also of the farmer adoption. Farmer adoption is always, an issue that faces researcher, especially when it comes to new crops and alternative crops. So what we are trying to do, according to our experience here in Morocco, is that to involve farmers from the beginning of the project. So what we do, especially kind of workshop with the farmers to, first of all, introduce them to the project and its activities as well. And then the approach that we are following on the ground is to install what we call demonstration platform or best practices hubs. So this is very important, and we do it actually at farm level, in their land, in their farm. And what we are trying to provide for farmers, especially the equipment, etc., and also the technical assistant during the whole project period. And this way, the farmers that they get familiar with the process, they get familiar with all the practices, the technical practices, and they learn about the crops, in close, relationships. So it's not like you are just inviting them to a workshop and just explain them about the new crop and ask them, okay, take the seeds and go cultivate them. It's very complicated process, very difficult. It takes a lot of time. It needs more several years to achieve it. But if you show, the success, if you show success stories about the crops to the farmers, I'm pretty sure that will not take a lot of time to get upscaled. So in one project that we are trying to implement, actually, so we have 5 platforms in the south of Morocco in different provinces, and of course we are trying to determine where the platforms, especially when it comes to salinity, they need to have a high salinity level, and we are testing several crops, and farmers they see at daily basis the growth of the crops, the potential of the crops, the harvest, etc., and they feed also their animals with this crop. So this way, the farmers is trying also to extend also the area of the cultivation. This is one solution actually. So through the demonstration platform, also what we are trying, especially when it comes to women cooperatives, especially in the valorization process and transformation process. So we are trying also to, of course, supporting them with equipments, with training, etc. And also we are, giving them the opportunity to participate in agricultural fairs, for example, in food fairs, to showcase their product and also to help them to create the market for their product. So it should be like a participatory approach, especially with smallholder farmers. When it comes to the agribusiness, they care mostly by the benefits. So they need, you need to show them the benefits, the income, production costs, etc. So, but smallholder farmers, they are actually the heart of this process, because they are the one located in marginal environment, and they are the one that they need actually our assistance and our support.
That's a really interesting point, Abdelaziz. I mean, do you think you can ever convince larger conglomerates or farmer groups to move into these saline areas, or do you think it will always be smallholders?
Yes, yeah, it's always, I mean, depending on the direction, the whole government is taking, and also the problem. If, for example, we have been working with larger cooperative for dairy, production, and with the increase of salinity problem, they are getting, interested to adopt this alternative crop. So now they are expanding. There is a government project in the south of Morocco of 9,000 hectares, irrigated with saline groundwater, and actually we are having 5 hectares in this big project, just to demonstrate to the farmers, just to assist them and to showcase the different crops and different potentialities we have in biosaline agriculture. So yes, I'm not just saying that just the focus should be on smallholder farmers, but also should be on larger farmers as well, and also on governmental initiatives as well, because when it comes to a large scale, here we have the governmental projects, and of course they need also our assistance and our support as well, as a researcher, of course.
Yes, great points. I mean, I could just sit here talking to you three forever, but maybe I should open up the floor to others. Does anyone have a question that they would like to ask to the panel? And so a microphone will come down to you in just 1 minute. Please introduce yourself before asking the question.
Thank you. I'm Shamal Muhammed. I'm working for Silal. We are an agri-food company in Abu Dhabi, Alejandro. We're really interested in your project and would like to kind of engage with you later stages. But I have a question for you. The project you mentioned with Masdar, would it be the same principle apply if we use treated water, for example, because it's a quite high nutritious, as well as there are some sort of perception within the public growing vegetable with treated water. But I believe in your case, growing Saliconia, for example, that might be another option.
Most definitely. I think that as if we live in Abu Dhabi, we know about the wastewater treatment issue is one of I think that can generate a lot of value as well. And very specifically, in the case of producing biomass that can be potentially not used for food purposes, but for energy purposes. And so, depending on the salinity of the water, of the treated sewage effluent in this particular case, or from some other, wastewater source, depending on the salinity, of course, one possibility is to use halophytes. But if the water is not that saline, we could potentially use the water to produce some other form of or some other crop that could potentially produce a feedstock that can be used and turned into energy. And very specifically, again, in our case for aviation, it would be extremely beneficial. And so, the focus of our consortium, the focus of the SBRC has been on halophyte agriculture, but we definitely are looking to incorporate other types of plants into that realm. And we are soon launching a new research center that will be looking at different I guess, other potential technology pathways that can be used. And so, yes, please, let's establish a conversation and see ways of taking this forward. Thank you very much.
The reason I asked that question, actually, one of the biggest problems for treated water is actually the salinity as well. So there is, for some reason, because of the distribution system, the pipeline is not good enough. There is a lot of sort of a seepage into the treated water. So when you look at the analysis, it's a quite high salinity, and that's probably where my thinking was, because it's already saline, so and high nutrition as well. So that might be an alternative, but definitely we'll link up with you and we'll take the discussion offline. Thank you.
Thank you.
So yes, what you do with wastewater is a really important issue. Biofuels is of course one solution, but what about forage crops? Bilquees, could you talk about using, have you used wastewater for growing forage crops?
Just use saline brackish water, not, so just saline water to grow and degraded land. So.
Okay, but I know that Abdelaziz, you've used wastewater, particularly to grow quinoa, for example, and possibly now to grow the forage crops. Could you also discuss about this as a viable option?
Yes, well, actually, it depends on the regulation that we have in each country. So there is, of course, a regulation, related to the use of treated wastewater in irrigation. But mostly in irrigation, we need at least to have a tertiary, treatment level, which mostly, eliminate the risk of bacteria and pathogens in the water. So in the irrigation with treated wastewater, we have to apply some measures related to irrigation system. Basically, we need to irrigate with drip irrigation system where we don't have actually a contact with the water, the water and the part to be consumed as a forage or as a feed. And most, advice is to use irrigation, for crops that will be transformed. I mean, just, that will be, of course, after maybe milled or transformed or cooked, whatever. I mean, just to eliminate the problem of health hazard risks. Of course, not use it directly to vegetables. This is very important. But for forage crop, I think it's most of the study that show that it's safe, as long as we, of course, respect this kind of measures using drip irrigation, avoid sprinkler, of course, and the treatment should be at least on one tertiary level, which is a bit safe for irrigation. Yeah.
Thank you for your answer. Should we move to the second question? Do we have, yes, audience member at the back?
Hi, my name is Faisal Khwater. I'm a high school research intern here at KAUST. So my question is, what are the roles of other technologies or ways to sustain agriculture in saline soils, such as using beneficial microorganisms or genetically modifying plants? And won't that introduce, other than halophytes, maybe introduce other crops such as cereal crops to saline farming?
Abdelaziz, would you like, or Alejandro, go ahead, please. Yeah.
No, just a quick comment. We're not, in our particular case, we're not doing any no genetic modifications of the Salicornia plant, but we are working with genetic information to improve the different aspects of the plant. And so we are taking genetic information. We are mapping, the Salicornia genome, and the idea is to be able to use this information so that we can actually breed potentially hybrids with vigor that will allow us to have a better commercial plant. And so by that I mean we want plants that have a higher salinity tolerance. We want plants that actually increase the yield of the oil seeds. And so we're looking for these traits that will allow us to do that in a shorter time, but not using not doing a genetically modified organism, but to use the genetic information to help us in breeding better plants. That's the comment that I wanted to make.
It's a very good point, and we heard from members of the Center for Desert Agriculture earlier today, the neo-domestication project. So if you've already got a salt-tolerant plant species that's wild, what you need to do then is to breed, and whether that's through traditional selection or marker-assisted breeding, or potentially through genetic modification, to get it to a level where it has the right traits that you want in a crop. Thank you for your question. I think we will move on to the question over here. Yes, okay.
Hi, I'm Klara Stanchevsky. I'm a PhD student working with Quinoa, so I'm mostly interested in Quinoa. My question is directed to Abdelaziz. I'm wondering if you could tell us a bit more about the challenges that you face with cultivating quinoa in the arid regions of Morocco, because that's very relevant to us here in the kingdom as well.
So yes, well, quinoa, it has a lot of challenges actually when we are cultivating. Yes, it's true. It's a resistant crop to salinity and to drought. I don't know if you still hear me, because I see Vanessa is appearing.
Yes, I can hear you. Yes, thank you.
Okay, so one of the challenges that we are facing, especially in early stages, especially the germination. Sometimes some varieties, they have a low germination rate, or there is a loss of the germination capacity of the seeds. So there is this problem of germination. There is also a problem of attacks, especially of some insects like caterpillars. When it's early stage, so they are very fresh. The plants, they are very fresh, and they are subjected to different attack of the caterpillars and also of the birds. Sometimes we have attacks of birds that they really eat all the plants that they have been germinated. Also, we have phytosanitary, problem related to mildew attacks, for example. If we are in a humid, conditions, so we will have development of mildew, which is affecting also the photosynthetic activities of the plant, and also reducing the leaf, area. And also another problem when, especially at maturity stage, when the plants get heavy, so we are having this problem of lodging. It's also problematic in quinoa, especially when we are trying to have mechanized harvest, for example, using the combined harvest. So we need to have standing plants, very fixed plant, etc. So the problem of lodging, especially when we have some problem of the winds, so it also affect the mechanization and the harvest issues. So one of the problem also, especially in the harvest or post-harvest, which is the content of quinoa in terms of saponin, which is get this bitter taste to seeds, the saponin. So we need to have tools to remove it. Of course, low-cost tools. Rather than washing, etc., do it manually. So we are trying to develop some kind of machines, like mechanical peeling, mechanical abrasion of the seeds to remove this, this layer, especially the bran, which contain a lot of saponin, which is a limiting factor also for quinoa transformation in the valorization process, of course. These are some examples of the issues. I'm sure that I forget some of the issues that we faced during our field, trials and production. Yeah.
I think it's a great point you raise, Abdelaziz. The using wild plant species like these halophytes, you're still getting issues, of course, with insects, diseases, and then you've got the added concern of the chemicals, bitter chemicals in the seeds as well. Bilquees, how do you find your non-conventional forage crops in terms of their palatability to the animals? Do they affect the animals in terms of their birthing abilities, or have you found any issues like?
We had already done some nutritive and anti-nutritive analysis of that fodder crop, and animal trials had been done, and after a year we feed a fodder crop for cows and then slaughter, and it was a nice barbecue party. So animals really like, especially cows, like to that kind of fodder. We just face it's hard to feed the goats, because mostly goats like grazing, but there's different methods local usually use. They just cut the fodder grass and mix with the other fodders and then feed. So we had already done animal trials and there's no problem.
Sounds very promising. Does anyone else in the audience have another question? We have time for one more question. Yes. We have one more question over here.
Hi, can you hear me? I am Juan Pablo Orsinegas. I'm a master PhD student in plant science here in KAUST, and I'm working with Salicornia. So my question is mostly direct to Alejandro. So you've been using Salicornia bigelovi for these systems, but what about incorporating the other Salicornias, the wild relatives, we could say? Have you considered using, I don't know, Sinus persica, Europea, and incorporating those Salicornias into these productive systems?
Yes, actually, we have worked with Sinus persica, and we have worked with some other halophytes that are not Salicornia. But without a doubt, Salicornia bigelovi is the one that has the largest seed production, oil seed production. And so in our particular case, because what we are after is the production of sustainable aviation fuel, we are looking, or we're pursuing the plant that will allow us to produce more oil per hectare. And so we have looked at other halophytes, and it is our plan to continue this work and to look at the different types of halophytes that are available locally and that are potentially able to help us in reaching that objective of being able to have a saline agriculture industry well established.
Thank you, Alejandro. So since we're running out of time, I'll just wrap up this session. Firstly, thank you to all of the panelists for joining me today. I think I could do a 2 or 3 hour session and just chat to you about saline agriculture. But I think what we've heard today is that there are many approaches which would be suitable for the kingdom, whether that's to use halophytes for forage crops, for example, for grazing of animals, whether that be cows or goats or even camels, which we didn't get to, but in my discussions, we've discussed the use of halophytes for camel grazing as well. Also, relieving the pressure on freshwater resources by using these halophytes is another important factor in the sustainable food production in the region. What I took home from each of you is that there's no one crop, one solution. So we need mixed crops, mixed cropping systems, even whether it's for biofuel production, to keep looking for those that get more biomass per drop of water, or whether it's for forage or food from quinoa, for example. Also, I've heard from each of you that we need to, the best way to go about implementing these strategies is to form both public and private partnerships, discuss with your local government and the broader government solutions that might be implemented in the region. And also I heard that it's important to reduce your risk by taking approaches to use mixed systems. So I've heard from Alejandro, for example, it's not just about aquaculture, it's not just about producing the seed oil, but there's also the mangroves as well for carbon sequestration, for example. Okay, so that wraps up our session, and I thank each of the panelists for joining me today. The next steps, we will have a breakout session at 2:30 p.m. And if you have been invited to these sessions, there's the food supply in Hall 1, water use in Hall 3B, food use in Hall 2, and environmental change in Hall 3A. If you haven't received an invitation to one of these breakout sessions, we welcome you to attend the open house of KAUST to see the spin-off companies, but also to see the facilities of the Centre for Desert Agriculture. And we welcome you to take tours and speak to some of our students who will be there hosting you. So thank you very much for joining me at today's session, and please join in me in thanking the panel.